All right, let's unpack this. If you've ever seen those amazing liquid effects in movies or games and thought, how on earth do they do that? Well, today we're doing a deep dive. We're looking at basic liquid animations right inside Blender, using its MantaFlow system. We're going to try and break down what looks, maybe super complex into steps that are actually pretty clear, pretty actionable for you.
Yeah, and what's fascinating here is just how much more reachable this stuff has become.
Yeah.
I mean, getting a handle on basic fluid physics in software like Blender, it's not just technical skill anymore. It's actually a really powerful tool for like visual storytelling, adding some seriously cool effects to your work without needing, a NASA computer or anything.
Totally. So, okay, let's get into the actual steps, the setup. Okay, so cube's gone. Then you need the main bits for the simulation. You add a domain object, usually another cube, which is basically the invisible box where everything
The
happens.
simulation boundary, yeah.
Right. Then you need something to actually make the liquid, the flow object. It could be a sphere.
It's sphere's common, yeah. It'll emit the liquid.
And then if you want the liquid to like hit something or fill something up, you add collision objects, like a bowl or maybe just the ground.
Makes sense. And the key thing here isn't just dropping these shapes in. You have to specifically tell Blender what job each one has in MantaFlow.
Okay, so how does that work?
Well, you assign the physics, the domain object, that big container cube.
Yeah.
You set its physics type to fluid, and then its domain type specifically to liquid.
Got it. Liquid domain?
Yep. Then your flow object, the sphere or whatever, that's also set to fluid. Flow type is liquid too, but then the flow behavior is important. Is it inflow, like a running tap? Or is it geometry, like you're starting with a blob of water that's already there?
Ah, okay. So different ways the liquid can appear.
Exactly. And those collision objects, the bowl or the ground, they get set as effector. And the crucial setting there is effector type needs to be collision. If we connect this to the bigger picture, these settings are literally the instructions for Blender. They tell it how everything should interact in the watery world you're building.
Right. Okay, so we've defined the players. Now, how do we get the liquid moving and looking, well, liquidy, not just like blobs?
Good question. This takes us to adjusting the settings. And this is crucial. Baking the simulation.
Baking.
So in the domain settings, you'll see resolution divisions. Think of this like the pixel count for your fluid. Higher numbers mean finer detail, smoother splashes. Maybe start with 64 or 128. You can go higher. But be warned, it really increases calculation time.
Right. Don't want to melt the computer on the first try.
Exactly. Then, under the cache settings, that's where Blender stores all the math it's doing. You usually set the type to modular. Pick a folder where it can save the files. Then you hit Bake Data. That does the physics number crunching.
Okay, so it calculates the movement.
Yeah, the underlying simulation. And then, here's where it gets really interesting. You hit Bake Mesh. That step takes all that physics data and actually builds the visible surface, the geometry of the liquid you can see and render.
Ah, so bake data is the how it moves. Bake mesh is the what it looks like.
You got it. It translates the simulation into something tangible.
Okay, simulation baked, mesh created, but it probably just looks like a gray blob at this point, right? How do we make it look like actual water?
Yeah, exactly. Baking is only part one of the visual process.
Yeah.
The real magic happens with materials and lighting. You absolutely need to apply a glass shader to the fluid mesh. That's what gives it the transparency, the refraction, makes it look like water, basically.
Glass shader.
And lighting is just huge. Using HDRI lighting, one of those image-based environment maps, gives you super realistic reflections and light bouncing around. Or even just a simple sun lamp can work wonders. But without good lighting in that glass shader, it just won't look right.
This raises an important question then. How critical are these final touches? Like, can you get away without them?
Honestly, not if you want realism. The physics simulation gives you the shape and movement, but the shader and light. That's what sells it as liquid. It moves beyond just physics into actual visual appeal.
Makes sense. So glass shader, good lighting, then what? Just hit render.
Pretty much. Set up your camera angle, choose your render engine maybe, cycles for that photoreal look, or Eevee if you need a quicker result, and then, yeah, render out your animation sequence or video file.
Wow, okay. So what does this all mean? if you're listening and wanting to try this. We've gone from that empty scene, deleting the cube, setting up the domain, flow, effectors, tweaking those resolution and cache settings, baking it all, then adding the glass shader and lights, and finally rendering. It sounds like a clear path, actually.
It really is. Once you get the workflow down for a basic pour like this, you've got the foundation. And, this is just scratching the surface. Think about where you go next. Mastering these basics opens up so much more. You could add splashes, make things interact dynamically, maybe create like really complex water effects for bigger scenes, the potential to enhance your projects, tell stories with convincing fluid. It's huge once you get past this first hurdle. Definitely something to explore.